I want to show where the quadratic formula comes from. The goal here is to turn standard form into quadratic formula. The very first thing that we're going to do is we want this first coefficient to be a 1. So we're going to take everything and we're going to divide it by a. That's what we're left with. Next part, we want to get this, which is normally just a number, over on the other side. So we are going to subtract c over a from both sides. Okay, this next part is where you'd want to understand how to complete the square. We are going to take this b over a, we are going to cut it in half, and we are going to square it. That value is something that we need. It's going to go into this spot, and in order to keep it balanced, we're also going to put it over on the right side. So just to kind of show you, if I take b over a and I cut it in half, it's b over 2a. But then I want to square it. So this is the thing that I want to add to both sides. So I'm going to add b over 2a squared on the left side. We're also going to add on the right side, but as I do that, I'm going to actually get rid of this square. So that's one of our exponent rules. So we're going to have b squared, we're going to have 2 squared, we're going to have a squared. The reason we did that is now this thing right here is what's called a perfect square trinomial, which means it can be factored into the form x plus something squared. We can kind of do these steps at the same time. The value that's going to be right here is going to be this thing that was over here, b over 2a. And here's why. You need two values that multiply to give us this. Well, if I take b over 2a times itself, that's the same thing as squaring it. And then we want it to add up to this term. Half of b over a and half of b over a gives us b over a. So that's where that comes from. Over on the other side, we're going to combine those fractions together, but we actually need a common denominator. So we're going to take this left fraction, we're going to multiply it by 4a over 4a. And then also at the same time, so I don't have to write it again, I'm going to flip-flop these. So I have b squared, and they're going to end up having the same denominator. So I'm going to be able to put them in a giant fraction. So I'll have 4a squared down here. But this will be minus, because of the negative, 4ac over 4a squared. And because we have the same denominator, there's our fraction right there. Now that we have that perfect square trinomial, to solve those, you do the square root, because that's how you undo a square. And we have to do the same thing over here. I'm going to use one of our other properties that we know. You can do the square root of the numerator and the denominator separately instead of the entire thing. So over here, we get x plus b over 2a. Over on this side, we're going to leave the top, how it looks, square root of b squared minus 4ac. And then on the bottom, because this is a multiplication, you can actually do the square root of 4, which is 2, and the square root of a squared, which is a. Last step when solving would be to get rid of this b over 2a, so I'm going to subtract b over 2a. They have a common denominator. This is going to come to the front side, which is going to give us the opposite of b, and then we have two possible answers because of the square root, b squared minus 4ac, and they had the common denominator, so we can keep that 2a on the bottom. And there's the formula.